to solve for a problem that involves fluid dynamics too, meaning that you see the word dynamics too, you immediately know there is movement involved. Kalau static ni memang tak ada, there's no what they call this whatsoever, there's no movement whatsoever. Okay, later you will see lah, you will understand better, alright? Alright, in certain cases, further subdivision into compressible fluids, which is gases, and incompressible fluids, which is liquids, okay? Nanti later, once I will explain to you what is actually compressible fluids lah. Alright, for now we are going to look into the incompressible liquids, okay? Alright, so example of fluids in food industries like thin liquids, like I told you before, not all of the sample is actually like the property is like water. No, you will be dealing with different types of liquid with different types of what you call this thickness, viscosity. So that's why you how do you say, you need to understand this particular fluid, okay, before you kind of like if you want to solve for any problems later lah, okay. So you need to understand the raw materials that is actually involved lah. For here, like example, thin liquids, like water, milk, fruit juices, which is really not that thick. Okay, sometimes if you were to transfer from one unit of operation to another unit of operation, you won't have much, what do you call this? You won't have much trouble. But when you start dealing with thick liquids like this, syrups, honey, oil and jam, you want to transfer from one place to another place, from one unit of operation to another unit of operation, then I told you before that you need to start, you need to have some kind of like assistance lah, like pumps. Okay, maybe you need to push it with something like a motor-like property lah, macam pump ke, mungkin ada, I'm not sure what it's called. Okay, tapi it needs some kind of an assistance lah in order for you to kind of like transfer this particular thick liquids, okay? Gases and nitrogen and carbon dioxide, okay, and then fluidized solids, which you need to fluidize first using the aeration of small bubbles, for example, like grains, flour and peas, okay? Alright, so an important properties of a fluid at rest is the pressure exerted by the fluid on its surrounding, whatever contains it, that is the fluid pressure. Alright, so it's okay, later I will explain to you. So pressure, force per unit area. So these are actually the variables that is actually involved in terms of the theory of fluid static, okay, the pressure. You will see a lot of this. You will calculate pressure for this particular fluid static, okay? So force per unit area, okay? Pressure is equal force per F over A. Alright, so weight equals to force, which is weight equals to mg. Okay, later nanti you will see why this is actually relevant lah in why is it that this particular two variables you need to know, okay, you need to know because you will see a lot of this if you want to solve the problem for fluid static and also in fluid dynamics as well, okay, you will see a lot of this. Alright, so thus force exerted, mg, betul lah, mg, I've shown you before. So mg, F equals to mg, so mass equals to, mass, I need to find, later I'll show you the pyramid of apa ni, nanti later I'll show you, I think I need to find it for a bit, kejap nanti I explain to you lah. Okay, so thus force exerted M equals to mg. How do you finalize here? Is because I think later it's okay, nanti I'll explain to you later. Instead of looking at this, nanti we'll look at the example of problems, okay? Okay, there's actually why actually it's VG, this is for force. Later nanti you will need to calculate. Tak apalah, nanti I explain. Very difficult to explain maths. Okay, alright. So where M is actually the mass, okay, the mass, G is actually the acceleration or gravity, V is actually the volume, density. Later you will see a lot of these variables being used, okay, in the equation of fluid static. Okay, what unit to solve for. So unit for force is actually Newton or kgms. Okay, be sure that you remember this. And unit for pressure is actually Pascal lah. Another way, if you see this, okay, you will immediately know this is actually also can be transformed into Pascal. This is also Pascal. Alright. So this is just how do you get this particular kgms. So if you see this is actually equal to Pascal, the unit for Pascal. Okay, for mass to remain equilibrium, the force it exerts to the gravity must be resisted by some supporting medium. Okay, for multi-story building, the upper floors must be supported by the lower ones so that you can descend the building of the burden on the floor until the foundation supports the whole building. So basically, if you want, this is actually a theory. Okay, if you want to build what do you call this, a high-rise building, you have to make sure this foundation is able to support the pressure on the top. Okay, here, because so this is actually similar to, this is actually a building. Okay, so this particular theory, okay, is also applicable when you want to kind of like solve for what do you call this, storage of your material lah. Material, especially for fluid. Okay, because usually for fluid you will store it in a tank. Okay, in a tank you cannot just simply store that particular fluid in a tank, so you have to be sure that the tank where you store this fluid can actually support the fluid. If the pressure, because you know that you know, sometimes if you want to build a plant as well, because it's not an open container, sometimes it is actually a closed container. When you're dealing with like closed container, a very closed system, you have to make sure that you will be able to the whole system can actually support the pressure that it holds. So you have to be sure to be able to calculate this. But that's why you need to, for this particular, what do you call this, for this particular week alone, for this particular course, the thing that you need to really measure is you have to look at the pressure. Okay, so if you don't handle this pressure properly, okay, if you, how do you say, if your system cannot kind of like withstand the pressure that this fluid holds, it could actually collapse. Okay, like here, if the foundation is not strong, it will collapse. Okay, so that's why you need to understand. Okay, there's actually ways on how can you actually calculate the pressure of each of the what do you call this, like kalau this building based on floors, but kalau in fluid, okay, let's say this is 1 meter high tank. Okay, you will be able to actually what do you call this, measure the pressure at each height. Okay, so you will understand better. Okay, so because at different heights, you will actually have different pressure. Okay, and you just want to make sure if you want to kind of like store the fluid, the baseline, this base or the foundation of this tank need to actually have the strength lah, the pressure, so that it can actually support the pressure on top of it. Okay, nanti later we'll explain. I'll explain, okay? So like I said, the same situation applies for fluid lah. The one that building the tower or the any building. Okay, so the lower level of the fluids must provide support to the fluid that lies above them. So sometimes macam nak kata when you deal with food how do you say, raw materials ni, sometimes your fluid ni is not only one kind of fluid. Sometimes it could be water, sometimes it could be oil. Okay, so it has these two has two different properties. It has two different densities. It has two different when you have two different density, okay, because density is another variable that is very important in order for you to kind of like measure this whole fluid static and fluid dynamic. So if you have different density, meaning that this particular two types of raw materials also have different, it will exert different different types of pressure. All right, so that's the thing that you need to actually bear in mind. Okay. Okay, so fluid at any point must support the fluid above. Okay, so make sure if it's stored in the tank, like I told you before, let's say this is water, let's say this is oil. Okay, the water here must be able to support the oil on top. Okay, if these are two types of property lah. If it's water, if it's just normal water the whole time, you just have to make sure that the water at this above level, the bottom one can support the upper level. Okay, so there's actually an equation that you can actually use to calculate, so you can actually know the pressure at each of the depth of this particular tank. All right, forces at any points. This is actually fluid at rest lah. Fluid static. Fluid static means fluid at rest. Okay. So basically, you have to know if it's static. Okay, you will have some sort of pressure that actually exert. Okay, this is the pressure of this particular fluid. Okay, so this is also, you need to consider the pressure outside of this particular liquid as well. Okay, so there's way. Usually this is called the atmospheric pressure lah. ATM, atmospheric pressure. This is the pressure of the fluid. Okay, this is the pressure of the fluid. All of these, okay, you need to calculate. So you get the total pressure punya value. Okay, so later I'll show you later. So consider a horizontal plane, okay, in a fluid at depth Z. Okay, where's Z? Here. Okay, below the surface of the density of the fluid is the density, here the density, the volume of fluid. Okay, never mind this. This is very wordy, but I'll explain to you later. But just to show you, okay, so basically the things that you actually need to know. All right, so this is for fluid static, right? Okay, let's say you have this a water filled in a bottle here. Okay, so you kind of like poke, what do you call this, you poke a hole in it. Okay, you can actually see the patterns of the water flowing. Okay, usually the bottom one is actually the fastest. Okay, it's because the potential energy is the highest here. Okay, because but if you want to calculate the potential energy too, what do you call this? It has something to do with height. If you still remember ke tak potential energy? Bila your car is at the top of the hill, okay, dia punya potential energy paling tinggi kan? Okay, so nanti kalau nak turun bukit tu, dia akan jadi laju. Alright, so if your car is here, the potential energy is less, so you punya, apa orang kata, you punya, what do you call this, you punya kereta akan slow lah. So that's why you have up to potential energy. It's something to do with height, okay, the height. So similar to here, okay, since the potential energy dekat lubang paling bawah ni, because of the height ni sangat tinggi, that's why it shoots the farthest. And this shoot the lowest sebab potential energy dia paling kurang. Okay, so nanti kalau if you have the time do this particular experiment ni, you will see lah. You should get this pattern lah. Okay, of water here, yang ni shoot paling jauh. Alright, this is fluid static lah. If you have a tank, your fluid is not moving, so you can actually use this particular theory lah. Alright, so the total force of area A must also include the additional force of the surface of the liquid. Meaning that, like I told you before lah, if you have a tank, okay, you have a, what do you call this? You have this particular liquid, you have liquid. You have to consider also the pressure outside, okay? So, let's see, it says the total force A must also include the additional force of the surface liquid. Dalam arti kata lain, this is just a fancy term. You have to actually include the atmospheric pressure lah. Okay, and atmospheric pressure ni you tahu always atmospheric pressure is always 1.01, 0.3 kPa. Alright, so don't worry about it. Nanti later just go straight. You do not need to actually derive lah this whole thing. this is actually deriving for you to how do you get this particular, this is actually the final, what do you call this, final equation. Okay, yang atas-atas ni is just to explain. This is very engineering lah. If you guys want to really learn, boleh lah extra reading. Tapi to me, what you actually need to know is actually you understand the concept of the potential energy, or what are the differences in terms of height. Okay, how does the height actually affects the pressure? Tu yang you guys have to know the relationship tu. And then finally, you just have to actually use this particular. I just want you guys to remember this, yang ni. Alright, let's look at this. Okay, for you to measure fluid static, okay, contoh, let's say this is a tank. Tank is actually, you can actually see the area. Area tadi kan, area. Okay, so volume equals to height over area, which is equals to volume. Okay, weight equals to mg. Alright, so tadi I have explained to you pressure equals to weight over area. Okay, which is weight is mg. This is the mass. That's the gravity. This is the area. Alright. So how do you get this? Okay. So how is it translated into this particular, what do you call this? Into this particular density. Density ni it's because, kejap density. So mg and then volume over, because this is fluid, so you will actually deal with density. So it will translate to Pg, kejap let me do this first M over A equals to density V A G. G is the gravity, V is the volume, A is actually the area, this is actually the density. Okay, so how did you finally get this? Because P, kalau perasan yang ni A equals to this. So H equals to V over area. So that's why the finalized version is PGH. Okay. So because originally you should calculate mass, but because this is actually fluid, you will actually change this mass into density. So this is actually the final, what do you call this? The final ni lah, the final equation. Okay, nanti apa-apa, what do you call this, any problems that you need to solve, you will actually go back to this particular equation specifically for fluid statics. Okay, that one I already explained to you lah. Why is this one is the farthest, why this one is the lowest. It's because of the potential energy. Okay, and usually if you were to calculate, usually pressure is highest at this bottom, the bottom part of the tank. Okay, and regardless, this is ni also regardless the size of the size or shape of the tank. Okay, meaning that it doesn't matter how the shape of this particular tank looks like. You I mean like you would, whether it's like here conical ke, okay, it's straight ke, I'm not sure kalau ada yang bulat ke. If you were to poke a hole in this particular tank, okay, if you were to poke a hole at this tank, it should get this similar pattern. Okay, it's regardless of shapes or sizes, because it's fluid static, it should actually obey this. Alright, regardless. So I mean like the shape has nothing, what do you call this, it doesn't actually affect lah. What actually affect here, if you were to really look at that, is actually the height. Okay, after you kind of like transform or derive this particular equation, you know that the variable involved in order to change the pressure is the density. Okay, it's the gravity. Usually gravity doesn't change much lah. Gravity is 9.8 something. Okay, that's the value. And usually it's the density and also the height. Okay, so like I told you before, the density maybe for water is different, for oil is different, so you have to actually calculate it. So even for water with certain types of salt, you have to calculate the density. Alright, so example. Calculate the greatest pressure. Allah. This is very engineering kesian korang kejap This is actually total pressure. Another name for it, okay? Total pressure. Okay, in a spherical tank of 2 meter diameter, like I told you before, so this is already meter. Kalau it gives you like centimeter, always remember the first thing that you need to do is change it to meter. Okay, alright. So you have to make sure lah. So nanti kalau given any calculation ke apa, the first thing that you need to do is to look at the unit. Kalau dia bagi centimeter other than meter, you have to change it to meter. Alright, so here it gives the specific gravity of this particular peanut oil. Okay, the pressure measured at highest point of the tank is 70 kilopascal. After that, calculate the total pressure. Okay, total pressure ni the greatest, maksudnya greatest pressure lah is the total pressure. So it would help, okay, for you to actually, so this the highest point of the tank. I'm not sure highest point of the tank. Kejap calculate dekat in spherical tank. So this is actually a spherical tank. Spherical tank. Is that like that? Okay, you ada peanut oil. You ada peanut oil. Alright, so meaning that the highest point, let's say like this is the highest point, okay? The highest point, total 70 kPa. I'm assuming je lah kan. And then you want to actually calculate the total pressure. Kejap I think there's something that I need to teach you before. Tapi tak apalah, nanti inilah kita tengok later lah, okay? So the pressure measured at highest point of the tank is 70 kPa. So they want to for you to calculate the total pressure. Let's look at this particular. How do you solve it? So the density of water. The density of water, is there water here? Density of oil. Okay, Z is the greatest depth. Dia ada bagi okay, 2 meter. And then specific gravity. This is what I say. Gravity ni, this is the constant value for gravity lah. It won't change. Okay. So now P equals to Z. Okay, Z is actually the height. Similar to height. This is another letter to represent height. Okay. So that's the density. That's the gravity. So the height is 2. So this is 920, which it has been calculated times with the density of water. And that's the gravity. So you got this particular pressure. Pressure ni is for peanut oil alone. Okay, so you want to calculate the total pressure or the greatest pressure. Peanut oil ni you tambah dengan yang the highest point of the tank tadi tu. So this is the total pressure of the cylindrical punya tank tadi tu. Okay, so this is peanut oil, 2 meter, but this is the highest point. Okay, that's 70 kPa. For peanut oil alone is 18.1. So the total pressure for this particular tank, yang ni tambah dengan yang ni. Okay, this I think for this particular case, it's considered a closed tank. Okay, if the tank is not closed, okay, like I told you before, let's say lah kalau bukan cylindrical, okay, if the tank is not closed, korang kena consider, kena tambah the total pressure dengan atmospheric pressure. Okay, make sure. Okay, so these are the things that you need to, apa orang kata, remember lah. Alright. Yes, this is what I want to actually show you. Have you seen this before? Have you ever heard of this? Gauge pressure, absolute pressure.
Yes.
Absolute pressure, yes. Okay. I think absolute pressure. Okay. Absolute pressure. Absolute pressure Okay, atau nama pressure atau nama lain untuk absolute pressure adalah total pressure, which are usually apa orang kata ni, atmospheric pressure tambah dengan gauge pressure. Okay, this is something that you guys have to ingat. You have to remember. Okay, so gauge pressure ni sebenarnya pressure, any pressure that is measured by a device. Nanti next lecture kita akan tengok all types of devices that you can actually use to measure the pressure. And all devices tu bila kita dapat the value of pressure tu, it's called the gauge pressure. Okay, so in order for you to get absolute pressure atau total pressure, depends lah if you are to be given contoh, apa orang kata, if you were to be given an example of cases or trying to solve for a problem. Kalau dia minta the value of absolute pressure, always remember you calculate for gauge pressure, and then that gauge pressure tu kena tambah dengan atmospheric pressure. Okay, so this is just an example lah, okay. A figure shown below the height of water and oil. Water and oil at 15 meter and 8 meter respectively. So you can see there's a differences in height here. Okay, container is open to atmospheric pressure. Sini perasan tak dia mention open. Okay, so dia akan mention kalau open atau closed tank. If it is open, always remember once you calculate for this pressure, don't forget to include the atmospheric pressure. Okay, tak apa, nanti kita try satu-satu. Okay, so what is gauge pressure and absolute pressure of the oil interface? Okay, what is the gauge pressure and absolute pressure? Bottom of the container. Okay, so it gives you the density of oil lah. Kalau density of water tadi, sebab dia ada water kan, it's always 1000 kg ms, is it? The density. Yes, kg m3. Right, so let's see how do they kind of like, okay, the first thing that they need to do is to kind of like find the pressure for each of these particular constituents, which is the, for this one is for oil. Is that oil? Yeah, I think it's for oil because it's 8 meter. Okay, so I think they are solving for A. Okay, what is the gauge pressure of oil-water interface? Okay, so the first thing that you need to do is, I think they calculate for oil first, oil-water interface. So 750 is the density, 9.8 is the specific gravity, 8 is actually for the height of this particular oil. So this one is for oil. Okay, so meaning that for oil, absolute pressure for oil-water interface, I think it only considers here. This here until here. So that's why you get this. You tambah dengan atmospheric pressure. This is the pressure for this sahaja. Okay, so because yang second ni we will actually solve for the bottom of container. Okay, so for bottom of container ni, so you have to calculate the pressure for oil, for water, and then finally you get to, because it's open tank. I told you before, because this is open tank, you have to consider the atmospheric pressure, you need to add this. Okay, so then this is the final value. Nanti later you tengoklah satu-satu once the lecture is finished. Okay, this one is in Pascal tau. So this is converted to kilopascal. Okay, 1 ni kilopascal tau. Okay, ingat. Remember to check the unit. So this one is this is in Pascal. Then you convert to kilopascal, that's why you get 205.8. Okay, then only then you convert to kPa, then you will actually add 101.3. Okay, so a bit dry lah juga lecture hari ni sebab calculation.
Betul, pressure sama je kan? atmospheric pressure semua sama je.
Sama, dia sentiasa sama. Dia memang constant yang telah dikalkulate oleh para saintis kita yang rajin dulu. It's always macam specific gravity lah. Specific gravity is always 9.8. Kalau atmospheric pressure memang always 1.1.3. Okay, kPa. Okay, so ni sama je. It's constant. Dia tak akan berubah nilai dia. Okay. Alright, so like I told you before tadi, other than understanding what they call this, understanding the apa orang kata ni, the pressure. So another way of seeing things is through ni lah, looking the common way of expressing pressure in terms of head. Head ni tadi ni lah, Z ni, H. What they call this, the height. Okay. So usually for engineering lah, engineering ni dia akan guna this particular term of head juga. Sebab macam this head also give them the idea of how the pressure will be. Okay, so tak apa, nanti kita tunjuk contoh of apa kata ni, cases tadi. So in a way P, which is the tadi lah yang kita dah ni, P equals to, supposedly P equals to apa tu, density Hg, okay. So cuma sekarang ni because it uses the term head, ini ganti dengan Z. So but if they use it interchangeably, you tahu that Z is actually H, it's the height, okay, it's the height. So usually kalau engineer tu they will actually use the term head. Okay, so kalau diorang discuss pasal head ni, you tahu they are discussing about the height of the tank ke, okay, the height of the, what do you call this, the height of the pipe ke, macam tu. Alright, so you know when they start to use the term head interchangeably, you tahu they are discussing about the depth atau the height. Okay, so like I told you before, like the pressure can also be expressed in terms of depths or heads, as they usually called of a given fluid. Alright, so the main reason for this method of expressing pressure is that pressures themselves are often measured by observing the height, the column of liquid that the pressure can support. So this is very engineering lah, especially for if you were to you know how engineers kan dia ada specifically untuk yang urus material kan, for raw materials ni. So meaning that they can actually know untuk oil pressure dia macam mana, usually tank dia besar mana. Because that particular height tu boleh support the pressure untuk material, contoh macam minyak. Kira macam if you want to store minyak dengan water, the height of the tank should be different sebab there are different properties, diorang ada different sets of pressure. Macam tadi kan oil lain, water lain, apa lagi jenis fluid yang ada selain daripada oil. Banyak lagi lah, macam kalau food industry, syrup lain, water lain, oil, syrup tu dia lagi berat. So you need to actually kind of like, so meaning that the size of the tank for different types of fluid ni kena berbeza juga. Because that particular tank kena support the pressure yang fluid to carry, okay? Alright, so example head of water. Okay, ni cases lah. If you want to discuss about the, what they call this, if you want to discuss about how do you want to, apa kata, visualize lah. If you want to discuss about, instead of you talk about pressure, you talk about the height. Contoh, okay, calculate the head of water equivalent to standard of atmospheric pressure lah. Tadi we already know that, apa tu, mula-mula P equals to ZPG, betul tak? Sekarang you want to know the height, okay, the height. So dia dah bagi maklumat pressure, okay, so maksudnya nanti you guys learn maths kan, so nanti Z kat sini, so PG divided by, P divided by PG sebab dia alih ke sini. Okay, nanti kat situ tinggal Z je lah, alright. So meaning that this is the final, this is actually the, what do you call this, the height. So meaning that if you want to store water dekat dalam tank, tank tu tak boleh kurang daripada this height. Faham ke?
InsyaAllah.
InsyaAllah. Kan, maksudnya sekarang ni korang dah ada pressure, Okay, the only thing is that okay, you want to build a tank. You dah tahu dah property of the fluid tu macam mana. Tapi you nak tahu besar mana tank, how big atau how high the tank should be. Sebab kalau once you calculate ni, macam contoh ni kan you dapat 10.2 meters kan. Maksudnya any tank less than 10.2 ni tak boleh store air tu sebab dia tak boleh nak pegang pressure tu. It will collapse. So it has to be either 10.2 atau more. Okay, so that kalau you want to discuss in terms of depth. So dia lain sikit. Alright, so kalau macam contoh, kalau you kind of like change this particular pressure into, kalau you change the pressure tu, you will be able to know the size of the tank yang you yang boleh simpan you punya apa orang kata fluid tu. Okay, so that's another way of looking at it lah. So contoh macam mercury kan. Mercury, head of mercury equivalent to 2 atmospheric pressure. Atmospheric pressure 1 times 2 lah kan. Betul lah, 2 atmospheric pressure. Okay, you see. You want to store mercury, the tank kecil je. Okay. The tank should be like the height of 1.5 meters. And it should be more lah. More than that. Anything less than 1.5 meter ni tak boleh store. Dia tak boleh pegang the pressure of the mercury tu. Okay, so that's how you kind of like look at it. Kalau you want to design a plant, instead of studying the pressure, you can actually look at this particular, if you already have the pressure, macam contoh lah, ni water you already know. Mercury ni something that, a property that you already know. Okay, you tahu pressure dia macam mana. Okay, benda yang constant yang dah dikira. So you want to know the tank pula, you want to design for a tank, you have to know. Macam tu lah. Okay. Alright. Tadi tu static. Dah settle static Sekarang kita nak tengok fluid dynamics. Okay, what happens if the fluid is moving? Okay, moving. Okay, in motion, fluid in motion is essential lah. So this is quite essential in the sense that memang mostly in the food industry ke any other apa orang kata any other engineering punya industry pun there will be like how do you say, the movement atau the motion of one, you need to actually transfer one raw material to another, from one unit operation to another unit of operation, okay. So once motion is involved, there ada another set of what do you call this, equation that you need to deal with, okay. Nanti benda ni, yang ni memang pening kepala sikit lah, tapi it's okay. I believe in you guys. Alright. So problem on the flow of fluids are solved by applying the principle of conservation of mass and energy lah. Macam yang kita dah belajar in previous class, meaning that you need to do a balance. Okay, balance. So apa yang masuk, hari tu energy masuk kena sama dengan energy keluar, raw material masuk kena sama dengan raw material yang keluar. Similar to this as well, okay. So how do you do the balance? Nanti kita tengok macam mana, okay, and what is actually involved. Alright, so the motion of fluids can be described by writing appropriate mass and energy balance, okay, the foundation of the design for handling the equipment. Okay, let's see. Ni dia. Alright, so contoh, this is an example of a pipe lah. A pipe in this particular apa orang kata fluid dynamics, okay, so that is actually the mass balance. Okay, let's see what is actually involved, okay, the variables involved in for you to do this particular mass balance. Let's see apa yang ada. First is the Z. Z is the height, good. P is the pressure. A is the area. Ni pun ni apa? Rho. Density, yes. Kat sini ada tambahan ni apa? V apa? Velocity. Velocity lah sebab dia bergerak. Okay, siapa nanti kita tengok. Excuse me, haus. Okay?
Doktor,
Ya saya.
yang doktor letak dekat Google Classroom tu tak sama dengan ni?
Lain sikit. Nanti saya post balik
Okay.
Saya baru perasan tadi.
Alright.
Nanti saya post balik yang ni Okay. Sebab dia tak ada yang warna yang ni kan. Dia tak ada kan?
Dengan
Okay, tak apa. Nanti saya share balik. Okay. Okay, so meaning that apa yang terjadi di sebelah kiri anda, it's your right. Okay, it should be similar on this side as well. So you can actually see there is pressure on this side as well. You can see the velocity on this side as well. You can see density and also area. Alright. Cuma height je lah. Height dia berbeza. Okay. We will see how height, macam mana the differences in height affect this particular velocity. Okay. Nanti kita tengok. Alright. So these are the things that you need to know lah kalau you want to do fluid dynamic punya balance. Okay. What is actually involved is the pressure, the density, the velocity and also the area. Okay. Okay, once system is working steadily, if there is no accumulation, like I told you before, ideally, which is very unlikely to happen unless it's a new factory plant, okay? No accumulation. So what goes in section 1 here, section 1, should be similar to section 2. It should be similar, alright? Fluid that goes in section 1 must come out at section 2. Okay, if the area of the pipe section is A1, okay, the velocity V1, density is V1, rho 1. So the corresponding values at section 2 should be A, V, and also density as well. So this is actually the balance that you should have. Okay, so what is actually involved is the density, is the area, and also the velocity. Alright. So this is the simple form dulu. Nanti kita akan, this will get more complicated but it's okay. You can do this. Okay. Alright. So if the fluid is incompressible, okay, incompressible macam tadi ada dua. Kalau gas, dia compressible kan. Kalau liquid, the incompressible. Okay, so because we are talking about fluid lah, so fluid is actually liquid, so kita akan we will actually label this as incompressible. Kalau incompressible punya fluid, very likely the density awal dengan akhir adalah sama. It will be the same. So meaning that you can actually take that out from the equation, leaving only A1 and also V1. A2, V2, because this will be the same. There's no point if you were to kind of like put this in this particular equation. Okay, so the finalized version of this equation is known as the continuity equation for liquids, often used to solve the flow problems. Okay, and nanti later if you were to find this particular lecture a bit too complicated, I will share you a YouTube video which actually simplifies so that you can understand better, okay? Nanti I post dekat you punya Google Classroom.
Okay.
Alright, so ni, I'm sorry because this nota ni very engineering-like, so it's very difficult for you to comprehend, okay? So tapi tak apalah, we'll just go bit by bit lah so you guys will understand better. Alright, for example, here, okay, whole milk is flowing into centrifuge through a full 5 centimeter. Perasan tak dia guna centimeter? So if you want to solve for this problem, the first thing that you need to do is to convert the centimeter into meter. Alright, and gives you the velocity, okay, in the centrifuge separated into cream of specific gravity 1.01 and skim milk into 1.04. So meaning, okay, this is not merely A1 equals to A2V2, okay? This is not merely A1V1, A2V2 sebab dia ada dua benda coming out, which is the skim milk and also cream. So meaning that A1V1 equals to A2V2 plus A3V3. Nampak tak? Dah start complicated. Okay, kalau water goes in, water comes out, A1V1 equals to A2V2. Now because you have two, maksudnya dia dah jadi A1 equals to A2V2 plus A3V3. Okay, let's say kalau ada 3 things coming out, A1V1 equals to A2V2 plus A3V3 plus A4, V4. It will depend on the outcome lah. Tapi whatever it is that goes on the, what do you call this, on the left should balance lah. Dia macam patutnya nanti this will actually perform some sort of a balance lah. You guys do chemistry kan? Dia macam ni jugalah, M1 V1 equals to M2 V2.
Faham.
Faham Okay, so whatever it is, macam nak kata macam mana pening kepala pun, okay, you have to make sure that there should be a balance lah. Okay, apa yang jadi kat sini, patutnya sini sama. Okay, so maksudnya A1, V1, okay. Kalau macam contoh A1 should equals to A, kalau macam contoh lah, sorry lah, kejap saya buat ni. Kalau A1 dengan V1, it should equals to A2 plus A3 plus A4. Betul tak? Just for you to understand the concept. Kalau V1 should equals to A2, V3 plus V4. Macam tu lah. Dia kena balance. Okay? It should be balanced. Sebelah sini kena sama dengan belah sini. Alright? Alright. So we know that here, okay, in and out. Okay, but like I told you before, sebab dia ada dua benda kat sini, dia tambah satu ni. Okay, if you have more, then you have to tambah lagi lah. Alright, but you just have to make sure apa yang jadi kat sini kena sama dengan apa yang masuk kat sini. Alright, so 1, 2, 3 denotes respectively the raw milk. So this is the raw milk, the skim milk, and also the cream. Okay. So also since the volume will be conserved, the total leaving the volume will equal the total entry volume apa tu? So, okay, sebab the volume should be the same lah, kan? Alright, so what happens is that kita main acah-acah bergerak-gerak lah ni You guys did maths kan? So, okay. So how did you get this? Okay, V2 daripada sini lah. Alright, so V2. So tadi apa tadi? A1 V1 equals to A2 V2 plus A3 V3, betul tak? Okay, so you nak dapat V2, that's how you get this. Alright, A1 V1 ni alih ke sini. Okay, A1 V1. So ni tambah kan? So ni jadi tolak A3 V3. Alright, so divided by V2. Faham tak?
A2.
A2? A2.
Divide.
Sorry, A2. A2 sebab kita nak cari V2. Betul tak? Okay, alright. So ni the first step that you need to do. Tapi tak apalah, apa orang kata, saya tak tanya kot soalan dalam exam, tapi tak apalah. I just want you to understand the concept, okay? So this is the first thing that you need to do, alright? So what happens is that once you guys dah dapat V2 ni, okay, kena tulis balik lah tadi yang tulis balik P1, A1, V2. Sekejap Okay, P1, A1, V1 equals to P2, A2, apa tu, V2. Tak apa, saya tulis dulu tau. Lepas tu tambah dengan P3, A3, V3. Betul tak? Yang ni yang original lah, original. Okay, what happens is that segala mak nenek ni korang kena substitute dekat dalam A2 ni. Sebab tu korang dapat yang ni. Betul tak? Faham? Hello? Faham, okay? So that's how you get that. Sebab korang substitute yang korang ni tadi. Dengar, faham tak? This is very engineering, tapi tak apalah kita main-main petang ni Ke ngantuk dah. Okay, so bila dah submit, okay. Submit lah pula. Bila dah substitute, you will get this lah. You masukkan ni dekat V2 tadi. That's why you get this. Okay. So lepas tu what happens is that you will get this lah. Okay, you dah substitute. So ni akan jadi P2A1V1. P2A1V1 because you need to darab ni. Betul tak? Saya pula dah confused. Okay, that's the original. Dah masukkan. So let me see this for a bit. So ni dah separate entity. So this one boleh potong. Okay? Nampak tak?
Nampak.
Okay, so nanti tinggal P2 A1V1 tolak dengan A3V3. Lepas tu plus here lah, plus P3 A3V3. That's how you get this. Betul tak? Alright, that's how you get this. Sebab korang dah potong ni. Okay, dah tinggal P2. Okay, lepas tu pening kepala Lepas tu kejap lagi yang ni bawa ke sini Okay, yang tu bawa ke situ. That's how you get, kita tahu ni kan, P1 A1 V1 tolak P2 A1 V1 equals to ni lah apa orang kata P3 A3 V3 tolak dengan P2 A3 V3. Okay. Lepas tu dia bawa yang kita selesaikan yang ni dululah. Dia bawa keluar P1 tolak P2 jadi P1 jadi A1V1. Belah sini pun samalah, dia bawa keluar P3 tolak P2 darab dengan A3V3. Alright. So once you dapat this particular B ni, yang A ni dah tak gunalah. You will use this. Okay. Then you will substitute lah. Area dia sebab dia mention ke? Diameter. Kalau diameter maksudnya dia silinder lah. Dia punya cylinder form. Right, so you have to calculate for the cylinder area. Sebab ini ada dua kan? Satu 5 cm, satu 2 cm. Okay, so just korang kata substitute the value semua yang korang dah calculate tu. And then you will get the final version lah for V3 and also V2. Okay. So you notice that for V3 the velocity untuk 5 cm is much more 5 cm ke tu? V3. Okay, betul lah V3. Okay, sebab sorry, yang ni dia tak kira diameter lagi kan. But you get to, tak apa nanti I'll show you another example lah. Tapi meaning that you will get to calculate the velocity for yang tadi V3 ni cream kan. This is also for skim milk. Maksudnya from this particular equation ni you will be able to solve for velocity for each of the material. Okay, and sepatutnya all this velocity add up macam V2, V3 should equals to velocity 1. Okay, contoh je lah, pening kepala kan, tapi tak apalah nanti korang tengok balik Okay, alright, so this is mass balance tau. Mass balance maksudnya raw material. Nanti ni we are looking at energy balance pula. Okay, so energy balance referring to the same diagram 3.3 ni, alright. We shall consider the changes in total energy of unit mass of fluid 1 kilogram section 1 and section 2. Tak apa, nanti I'll show you the example lah later so you tak pening sangat. Alright, so the energy involved, okay, sebab it plays with the height. So here are the, apa orang kata, sebab potential energy usually akan change to kinetic energy lah sebab ada movement. So the potential energy meaning that the height will actually affect the pressure and also the kinetic energy. Kinetic energy ni sebab dia involves in motion. Okay, motion, kinetic energy. So usually potential akan tukar kepada kinetic energy. Okay, kinetic energy atau mechanical energy. Alright, so these are the three energy that you need to bear in mind lah kalau you want to kind of like solve for fluid dynamics, okay. Pressure energy obviously lah, memang we've been solving for that, for pressure energy too. Alright, secondly, there may be energy interchange with the surrounding, like energy lost to the surrounding due to friction. This is very highly depending on the types of fluid lah. Okay. There are different types of fluid. Nanti later by the end of this particular lecture, or maybe I ask you to do an assignment on that lah. Alright, nanti you will know actually, have you heard of Newtonian fluid and dengan non-Newtonian fluid? Pernah dengar tak?
Pernah.
Pernah kan? So you know kalau Newtonian fluid, whatever force or pressure that you apply to that fluid, the viscosity does not change. Contoh dia water. That is Newtonian. Kalau non-Newtonian fluid, whatever pressure that you apply to that particular fluid, dia punya density will change. Sama ada dia akan jadi more apa orang kata, more thick atau more thin. Tapi tak apalah, itu nanti kita tengok balik lah. Alright, so like I told you before, it depends on the apa tu orang kata, types of fluid. Alright, the mechanical energy, like I told you before, kalau the fluid gets really thick and it's not like water-like property anymore, of course it will need some kind of a system to transfer it from one unit operation to another. So you akan kena ada pump, dia macam you will need like pump ke, motor ke, rotor ke, to kind of like assist the transfer of this particular material, okay. The effects is heat energy in heating and cooling of fluid. Nanti for this part ni, nanti kita akan belajar more lah dekat dalam heat transfer pula. So these are the things that you actually need to kind of like consider. So sekarang ni kita belajar in pecahan. Tapi nanti by the end of the course, you will actually jumble all of this together, then you will actually know. Macam sometimes it's just not, apa orang kata, it's not just the fluid alone. Kadang-kadang kalau cooling, cooling lain pula. Nanti kadang-kadang ada, macam contoh you guys want to make ice cream. Ice cream tu is not only cooking. You have to remove the heat so you can actually solidify the ice cream. Those kind of things needs to be put into perspective. Alright, potential energy associated with restoring forces such as spring. Okay, the potential energy is the energy that you simpan lah bila you tidak bergerak. Alright, so the action of stretching the spring or lifting the mass is performed by external force, work against force in the field of potential. Alah ni yang just to explain to you that apa orang katakan ada spring kan, gitu. If you still remember lah you punya fizik kan. So if it's not stretched, okay, there's no force to it. If the apa orang kata the spring is macam duduk diam-diam tu, it's still in the form of potential energy. Okay, once you get some work done, you stretch this particular string tu, tu dah jadi benda lain lah. I think dia dah jadi orang kata kinetic energy lah kalau ada movement lah. Alright, so potential energy tu contoh yang spring tu lah. Alright. Alright, the stretching of lifting performed by external forces work against the force of field of the potential lah. Alright. So meaning kalau ada external force, it will actually disrupt, okay? It will disrupt the potential energy tu. Alright. So this work is stored in the force field which said to be stored, okay? Senang cerita potential energy ni stored energy lah, okay? Contohnya macam kalau dekat atas apa orang kata kereta tu kan, dekat atas bukit ni kan, dia apa tak bergerak kan. So kat sini dia potential energy lagi. Okay. Stored. Alright, kalau ada external force, remove from the tadilah kalau macam the external force is removed, maksudnya this particular spring will go back into its original form. Maksudnya dia akan retain balik lah the original potential energy dia. Energy, okay. Ni semua fizik masa high school lah, alright. Tak apalah, you just nanti boleh baca ni potential. Ni contoh potential energy. Alright, so I think this kind of thing apa orang kata ni, you don't, apa tu kata nanti balik korang baca lah, but I think I just want, nanti I take your attention to apa orang kata ni, another equation. Yang penting kat sini Bernoulli's equation, nanti I tunjuk kat sini. Pernah dengar ke Bernoulli? Pernah kan? Korang bagi tahu last week.
Pernah.
Pernah kan? Okay. Apa, this is for your reading lah. Apa itu potential energy, apa itu kinetic energy, apa itu pressure energy. Okay, this later you can go back and have a look at the at it. Okay, boleh baca lah. Tapi by the end of the day korang tak guna pun ni nanti. Okay, this is the fundamental concept of this potential energy, kinetic energy and also pressure energy. Okay. Tak apa, nanti balik boleh, apa orang kata, boleh baca. Alright, friction loss. Okay, when the fluid moves through a pipe or fittings, okay, it encounters frictional resistance. Okay, and energy can only come from energy contained in the fluid. So frictional losses of drain of energy resources of fluid. Yang ni, kalau boleh, it's easily to say that frictional ni is unfavorable. Unfavorable. Tak apa, yang ni kita akan discuss next lecture. Okay, next lecture. Why is this, apa tu orang kata, unwanted lah, why this is unfavorable. Okay, so the drain of energy from the resources fluid lah. So nanti kita akan discuss lah, like I told you before, ideally you can actually transfer one fluid to another fluid tu. Zero accumulation. Tapi like I told you, as time goes by, dia akan ada start build up. Okay, this build up will actually create more friction. Okay, so this is something unwanted lah. So this is actually a problem you can actually probe bila you buat energy balance untuk this fluid dynamics. Okay, alright, so friction ni unwanted. So bila you nampak ada problem dekat this particular, bila ada friction ni, you will actually, there might be an increase of heat. Okay, tu salah satu cara untuk detect. Lagi satu, there will be a change in velocity and also the pressure, sebab bila diameter berkurang, alright, the velocity will actually increase. Kalau velocity increase, pressure juga akan change. Sebab tu kita akan guna Bernoulli's equation to solve for this particular problem, friction loss ni. Okay, alright, so you can actually read this later, mechanical energy. So this is all, apa orang kata ni, this is all fundamental lah. Alright. Okay, ini contoh turbine lah. Kalau turbine, nanti I think next lecture you will see all of the types of turbine, motor, rotor, pump untuk transfer this fluid from one unit operation to another unit operation. This is just apa orang kata, contoh where energy might come from. Okay. Kalau turbine ni potential energy ada, kinetic energy ada, mechanical energy pun ada. Alright, so this particular thing will actually exert energy, okay, to help transfer fluid. Okay, so energy balance is very important. Usually energy balance ni dia akan detect through the change of heat juga, temperature lah, temperature. Like I told you before, dia akan boleh detect to temperature, pressure and also the velocity. Okay, so these are the things yang very important for this particular energy balance ni. Okay, tengok, heat might be added or subtracted, okay, in the cooling process. Okay, so usually kalau addition, let's say lah, kalau macam contoh you build a factory plant, okay, you are familiar with the system, you will know how much heat, macam kita nak masak lah, contoh kalau you want to bake a cake, so you akan panaskan oven at 360 degree Celsius, macam tu lah. Alright, contoh. So this is usually known, okay, usually known, this is the numbers that you know. Okay, the numbers that you know, the numbers that you play around with. Okay, so kalau macam ada problem, dia akan macam, let's say you heat the oven tapi something is wrong with the oven. Okay, 360 ni dekat probe ni dia tak akan detect 360 degree Celsius. Mungkin ada lebihan ke. So that's how you detect if something is wrong with that particular oven ke, with that particular orang kata processing unit ke. Okay, So you need to know. Sebab tu kata you have to understand your plan, okay? Even before when you start to design that particular plan. And usually all this theory ni orang engineer lah yang tahu, okay? Sebab tu engineers are very apa orang kata important lah. In any apa orang kata factory atau industri yang macam ni lah, alright? So heat might be added or subtracted, okay? Cooling process ke, it depends on your ni lah. Like I told you before, kalau you buat apa ni? Kalau you buat ice cream, mula-mula you panaskan whatever it is that you need to panas, and then last sekali you will remove the heat, okay, for cooling processes, stuff like that. So compressibility terms might also occur, gases, okay, but when you deal with low pressure only. Contoh, kalau gases ni, imagine kalau you guys buat carbonated drink. Carbonated drink tu ada gases. Kalau you ada gases tu, that's a whole different story. Tadi tu macam dah jadi macam compressible fluid. Tu lain pula. Okay. But I'm not sure if I'm going to discuss this in detail for this course. Tapi tak apalah. Alright, just for you to kind of like bring things into perspective. Alright. So tak apalah, this one equation you can read later lah, alright. So but this is actually the Bernoulli's equation, but I'm not going to ask you to remember this one. Sebab macam complicated sikit. So I jumpalah seorang cikgu ni, dia permudahkan. So it's easy for you to understand. Tadi yang kita discuss ini, continuity equation. Now we're looking at this. Continuity ni untuk mass. Ni untuk energy. So apa yang kat sini sebenarnya, it's translated into this lah, which is much more easier. Alright. Alright, so untuk conservation of fluid lah, conservation energy fluid ni, untuk Bernoulli's ni, for Bernoulli's ni, okay, so kalau kat sini, alright, this is actually the bukanlah similar, it's the concept is still the same, okay, for continuity and Bernoulli's equation. Only that for Bernoulli's equation ni, they start to introduce the height and also the density. The density of this particular, what do you call this? Properties lah, okay. So if you were to look closely, sama je sebenarnya ni. Tapi you just have to, apa orang kata ni? Susun balik lah. Tapi I think we just go straight to this uncle lah, uncle here cikgu ni. So the first thing yang tadi kita mention adalah pressure energy, which is P1, okay. And then potential energy because it plays around with the height. Remember what I told you before, potential energy memang akan bermain dengan ketinggian. Okay? And then look at kinetic energy. Kinetic energy dia akan bermain dengan velocity because there is motion. Understand?
Yes.
Yes, okay? So sama je lah macam tadi, A1, V1, density 1 semua tu. So what happens on this side should equals on this side, okay? I just want you to understand the concept lah. Sebab saya rasa in exams, I will not ask you the calculation semua lah. Because to me, if you understand the concept tu lagi penting lah, alright? So let's ni. So contoh macam ni, nanti I'll give you a lecture, this uncle punya lecture to you guys lah, so you can understand better, okay? Alright, so it's just that you need to know for Bernoulli's punya principle, okay? If you were to reduce the diameter macam sini kan, okay? If the changes in velocity and pressure, okay, is depending on the height and also the diameter. Okay, so sinilah. Okay, sebab sometimes like kalau kita tengok balik dekat 3.3 ni, macam ni kan. Sometimes kalau you build a factory plant ni, this pipe is not going to be on the same level. There will be differences in height. Macam dia pasang kat sini, dia naik, lepas tu dia pasang, lepas tu dia turun balik, lepas tu dia naik balik. So this changes in height will actually affect dia punya potential energy. Bila dia affect potential energy, it will actually affect the velocity as well. Okay, so benda tu dia akan calculate lah at every height. Okay, so always remember, cuma satu je lah. As you remember, you need to remember kalau the apa orang kata the diameter apa orang kata reduces, the velocity increases. Tapi bila velocity increases, pressure akan reduce. Itu adalah orang kata apa, Bernoulli's equation tu. Nanti I'll give you the lecture for you to understand better lah. Okay. So this fluid dynamics ni sama juga in terms of apa orang kata ni, if you want to fly an airplane, sebab dia play around with the pressure of the air. Air is actually gas. Gas boleh guna Bernoulli's equation lah. So it plays around with the potential energy, kinetic energy and also the pressure energy. Alright. So I'm not going to go through this fluid dynamics ni. Sama jugalah here. Tahu kan kalau macam budak lelaki gosok baju tak?
Gosok.
Gosok. Korang ada spray tak? Anak dara spray.
Ada.
You guys tahu kan kalau nak hilang kedut korang spray air sikit kan? So you know that spray, you tahu kan the nozzle tu boleh tukar whether you want to get air yang straight atau air yang macam aerosol sikit.
Yes.
Tahu kan? Yang teruna tahu tak?
Tahu.
Tahu, ya ke tahu? Tahu tak? Ya mesti tak pernah kena. Okay, so what happens is that usually the girls know lah kalau diorang nak, kalau apa turun bawal ni nak spray-spray sikit kan. You guys perasan if you change, okay, if you change what do you call this? The nozzle tu, you actually change the diameter tau. The diameter of that particular outlet where the spray keluar tu. Kan, kalau ni kan spray. Okay. Kan, kadang-kadang kalau you guys tak alter orang kata apa, the diameter kat sini, air akan pancut keluar straight je. Tapi korang kalau you guys want to dapat yang aerosol tu, yang macam air, you guys apa tu boleh pusing kan. So in order for you to get what do you call this, this is considered nozzle juga ni, nozzle. So if you change, okay, if you change that particular diameter tu, you will be able to kind of like alter with the velocity. Bila velocity tu tinggi tu yang you dapat aerosol punya properties tu. Macam tu lah, that's the principle everyday thing that you use lah untuk this particular fluid dynamics yang in nozzle ni. You can actually read this later lah. Alright. I'm not going to discuss this thing, it's okay. Okay, now we're going to look at viscosity. Tu dah settle lah kira dah settle what do you call this? Settle bahagian fluid dynamics lah, okay. So remember fluid dynamics ada apa? Ada static, fluid ada static dengan dynamic. Kalau static you have to remember height, density, apa tadi? Gravity. Okay, ni kalau fluid static. Kalau dynamic tu dia dah complicated sikit lah. Yang continuity tu A2, V2, lepas tu ada potential energy, kinetic dengan pressure energy. Okay, these are the things that you need to remember. Jadi saya tanya, okay. Saya tak adalah minta calculate benda, malas. Saya pun malas nak check. Alright. Now we're going to look at viscosity. Why is viscosity important? Like I told you before, viscosity of a property ni, it's not always going to be like water. Alright, so viscosity of a fluid, okay. Alright, this is actually material science material science for fluid, okay. So, sorry. Okay, viscosity, this is actually a type of material science lah. Viscosity, how do you actually get the, apa orang kata, viscosity ni? So this is actually another branch of study called the rheology study. Rheology study. Siapa yang buat FYP dengan saya akan belajar benda ni lah. Alright, so rheology study. So in order for you to get the value, the viscosity of a fluid, okay, you nak understand a certain property of your fluid tu, you will need to do rheology study. And in order for you to get rheology study tu, okay, you need to find out the viscosity. Viscosity is actually it explains the property of that fluid. Okay, in order for you to get this viscosity, the machine, okay, used to measure viscosity ni is called the rheometer. Okay. This rheometer ni yang akan calculate dia punya deformation shear stress ni. Okay. Alright, so this is actually the fundamental that lies behind rheometer. Okay. So particularly, how does this particular rheometer function? Is that rheometer ni dia ada satu, apa orang kata, machine dia looks like, saya ada ke rheometer punya gambar? Tak ada. So rheometer dia macam ni tau. Dia machine dia lebih kurang macam ni lah. Okay. Sini dia ada static plate lah. Static plate. Okay. So dia ada satu probe. Probe kat sini. Usually dia probe macam tu lah. Okay, usually ni static plate lah. This is the static plate kat sini. Okay. So what happens is that nanti korang akan letak sample dekat celah tu. Sample, okay. So nanti this particular probe tu akan turun dekat static plate tu. Dia akan gerak. Dia akan pusing ke dia gerak. Lebih kurang macam orang kata ada movement lah. So that particular movement ni, okay, ni contoh ni sample Ni sampel, and then nanti ke atas ni ada yang probe yang dipegang tu. Okay, pegang. Ni probe. Ni yang atas ni Lepas tu yang ni static plate. That's the static plate yang kat bawah tu. So meaning that sample tu ada in between ni. Okay, so nanti benda ni akan berpusing sebenarnya, tapi kita tak nampak sangat sebab dia berpusing dalam kadar yang very slow-mo lah orang kata. So dia akan deform, dia akan gelakkan gel tu a bit jadi macam ni. Dia akan deform to this particular, dia akan deform untuk jadi macam ni lah. Nanti dia akan ada cara calculation dia. Nanti kalau ada calculation dia, okay. Okay. Nanti adalah angle. Macam mana? Saya tak tahulah korang kena tahu ke tak benda ni. Tapi this is how diorang measure lah angle ni. Dia ada mathematical equation dia. Tapi that particular rheometer tu akan bagi the final viscosity punya value. You guys don't have to calculate it. Tapi you guys have to know the fundamentals that lies behind this rheometer lah. Alright, so this viscosity ni, okay, how do you get this viscosity is this shear stress lah. So the movement yang cause the change in the bentuk sample tu is called the shear stress. Dia guna this particular tau. Nama simbol ni tau, okay. Alright, and then shear force divided by the area. So dia akan ambil kira area ni lah, area of this particular device tu lah. The static plate dengan movement plate tu. Okay. So bila once you calculate this, you akan dapat viscosity tu lah. Okay. This is just to explain to you how this rheometer works. Okay. Apa itu shear stress, apa itu shear force divided by area. So viscosity is actually the measure of thickness, atau dalam bahasa Melayu dia the measurement of kelikatan of that particular fluid. Okay. And viscosity is the property of fluid that gives rise to the force that resists the relative movement. Maksudnya, macam tadi kan shear force kan, macam ni. Shear stress dengan shear force. Okay, usually kalau this machine, dia detect it needs more force untuk gerakkan dia, maksudnya that particular material tu, viscosity tu very thick. Okay. So kalau kalau macam you do not need much force untuk deform dia atau gerakkan dia yang ni, maksudnya the viscosity is actually not, the viscosity tu very light lah atau thin. Okay. And one more thing that you need to do, viscosity yang rheometer ni dia akan immediately measure sample yang non-Newtonian. Sebab usually kalau buat apa dia nak measure kalau dia apply force tak ada change in the viscosity. Betul tak? Okay, so kalau you ada sample, macam if you were to learn about apa orang kata material science atau apa tu engineering in material science tu, kalau you tahu you have a certain material tu, you akan immediately check for that material bersama ada dia non-Newtonian atau Newtonian fluid. Kalau apa orang kata, kalau lagi satu yang tu rheometer kan untuk measure fluid. Kalau let's say you have gel yang keras. Contohlah kan dekat dalam food industry kan kita akan deal with gel. Kalau gel yang solid macam ni, kita tak akan guna rheometer, kita akan guna this thing called the texture analyzer. Nanti you guys can go back lah untuk check apa itu rheometer. Boleh check machine dia macam mana, apa itu texture analyzer. Alright, this is very interesting tau untuk siapa yang berminat lah nak study material science, okay? Alright, so viscosity is that property of fluid that gives rise to forces. Yang tadi lah kalau dia ada resistance tu, dia viscosity dia akan ni lah, akan lebih likat lah. Alright, the rheometer will actually measure that for you. So this is just the fundamental that lies behind the rheometer tu. Alright, it describes the internal friction of a moving fluid. So kalau friction dia tinggi, maksudnya dia punya thickness is very high. Kalau friction dia rendah, maksudnya the thickness is quite light atau very thin. Alright, so this is just another apa orang kata viscosity, okay, force over area, and then you can see that's the viscosity, that's the velocity and also the height. These are the apa orang kata variables that is actually involved in measuring the viscosity lah, okay, the mu. Alright, tak apa. I'm not going to explain this to you sebab this is what this is the apa orang kata ni, the fundamental that lies behind the rheometer lah. Tapi kalau you want to do additional study boleh je, but I want you to actually look at this here. This is non-Newtonian fluid alright. So non-Newtonian fluid ni is very interesting, okay? Sebab okay, you want to kind of like label apa tu a certain fluid into Newtonian dengan non-Newtonian ni tu yang you kena measure dia punya apa orang kata, you kena measure dia punya viscosity. But also with rheometer you boleh also further study sama ada a certain apa orang kata, a certain fluid tu bila kita letak force sama ada dia akan jadi thickening atau thinning. Okay, tapi tak apa, kita akan tengok ni apa one by one. Okay, all other fluids are called non-Newtonian. Kalau yang I told you before, kalau water you apply any force the viscosity won't change. Tapi untuk non-Newtonian fluid ni, once you applied a certain force, dia punya property memang akan bertukar. It will change, okay? Alright, so there are different types of non-Newtonian fluids, which is thixopractic, pseudoplastic, dilatant, Europactic and Bingham fluids. Alright, so
Betul.
yeah,
Newtonian fluid water je lah.
any fluid yang bila kita letak force tu, water tu contoh, tapi saya rasa water je sebenarnya. Tapi you guys can have a, apa orang kata, maybe korang boleh carilah. Tapi yang saya tahu, any types of fluid tu, bila kita apply force kat dia, dia punya viscosity tu tak berubah. It's always zero. Bukanlah zero, it's always the same. Macam tu lah.
Okay.
Nanti apa ni? Banyak video tu nanti. Contohnya, korang pernah kacau cornstarch tak?
Pernah.
Pernah kan? Korang perasan tak? The harder you kacau dia, the thicker it will be. Betul kan? Ya ke? Betul. Masuk dapur ni. So, alright, so tapi usually Newtonian yang saya tahu water lah. Tapi nanti maybe you guys can give me some example ke untuk next week's class nanti. Alright, so ini ada different types of non-Newtonian plastic. Like I said, non-Newtonian plastic, kalau you apply any forces, dia punya properties of viscosity tu memang akan berubah. Alright, contoh alah, saya tak suka graf ni. Ada graf lain sebenarnya, tapi tak apalah. Alright, so this is actually shear stress, this is actually force sebenarnya. Okay, this is actually force, sebab nampak tak? Force. Okay. force. Okay, shear rate. Okay. So N is actually the viscosity. Alah, saya tak suka sangat guna apa orang kata ni, this particular. Tapi nanti next week saya bagi another form of this apa orang kata? Graph. Dia ada lagi satu graph yang lagi senang korang faham as compared to this one. Okay, it's just that dia lebih kurang sama je, cuma yang ni dia engineering sikit. Tapi nanti next week saya tunjuk another apa orang kata ni, another graph yang lagi senang nak faham in terms of non-Newtonian ni. Okay, so pseudoplastic, for example, like I told you before, viscosity decreases kalau ada force. You put if you put force, okay, just ignore shear lah. Let's just talk about force. Okay, if you increase the force, okay, the viscosity tu it will actually decrease the viscosity. Alright, so maksudnya kalau korang kacau, let's say you have this particular material, korang kacau tu, as you put more force to it, apa orang kata tu, dia akan lebih cair. Okay, it will get really thin. Alright, so example, tomato puree, ketchup, paint and nail polish. Alright, shear thinning, maksudnya as you put force, dia akan lebih thin. Okay, dia akan lebih cair. Kalau thixopractic, in extreme cases, ni rare cases lah, where the shear force are low, there may be no flow at all until a certain yield stress. Maksudnya yang ni, yang thixopractic ni, thixopractic tak ada kat dalam ni, dia macam Bingham juga. Thixopractic ni maksudnya kita apply apa? Let's say kita apply force, okay, force kita apply force tu, dia still dia punya viscosity tak change. Tapi at one time tu bila you start kacau kuat, dia dah exceed certain force tu, dia memang ada satu value force tu, dia punya once you exceed that force, you exceed dia punya force point tu, dia punya viscosity akan berubah, dia akan jadi thick. Tu thixopractic. Okay, so meaning that kalau korang kacau saja tu dia tak rasa sangat lah. Tapi you start to put a very huge force, lepas tu dia akan change dia punya property untuk jadi thick, dia lebih thick. Alright. Macam dilator ni lebih kurang macam ni lah, tapi dia tak perlukan dia tak perlu extreme force lah. Yang ni dilatant, viscosity, as viscosity increase, ni yang confla tadi lah. Okay, as viscosity increase, dia punya apa orang kata ni, dia punya viscosity akan increase. Alright. So sama rheopactic, more extreme condition, zero apparent viscosity under low shear, sama juga macam ni tadi, thixo juga. Okay, nanti later I'll try to find video lah, I'll share the link with you guys. Sama juga Bingham. Bingham ni pun, if you notice, dia kena exceed certain force baru dia akan change in property. Sama juga dengan thixopractic, adik-beradik juga. Thixo apa? Thixotropic. Ni sebenarnya adik-beradik ni dengan ni. Alright. So I think that's it for today. I hope I capture all of the important parts for fluid dynamics ni. Ni baru part 1 tau korang. Part 2 nanti lagi. Part 2 nanti you guys start to see Reynolds number, yang laminar flow, turbulent flow. Yang tu macam pening sikit. Ni dah pening dah kan, nanti pening lagi. Alright guys. Thank you for today. Sekarang.
Okay, thank you Doktor.
Alright.